So in the simple way, you can say we are not getting resources so that we can get this data from here to here, right? Okay. So this is what happens in our normal database system. Consider this as a database here, and you have its Smith information stored here. Now there are real-time guys here who are accessing the Smith information. So what will happen here? Every time they are all accessing the Smith information, but they will be in the queue because this tunnel is not free so that they can access the data from here to here, right? So what Oracle thought here, what if everyone accessing the same thing here is Smith information? So what if I put this information in the memory? So they don't need to perform IO. So that is why Oracle came up with some different concept. Now what Oracle did here, again the same thing, this is my database here. Okay. And here it here, memory. Now I'll write it here. This is your memory and this is your database, and here your Smith information is stored. Okay. Now same situation, there are some 100 real-time guys will be accessing the Smith information. Now first time when this guy is coming to access the Smith information, it will come from the memory here. First it will check whether this information is there in the memory or not. If it is not there, then it will go to the database. So again same thing, here IO will be performed, right? The same thing will be here, that tunnel, and here will be your disk controller. So here it will perform one IO and it will get the data Smith, it will get the Smith information, and what it does here, it will put this information in the memory here. Okay. In the memory, and then it will give this information to the user. Okay. So this is how this user will get this information. The next time what will happen? Next time when this user is accessing this information, when it will come here, this information, it will go check here, it will find, okay, Smith is here itself. So what it does here, from here itself, it will transfer this information to this user. Now we don't need to perform one IO. See, now this information is stored here. So what we did here, we reduced the IO. When IO is not coming into the picture, then no performance issue. So this is what Oracle thought. Now whatever recently accessed data will be there, we will put in the memory, and then other users who are accessing the same thing, they will get the data from the memory and they will do the things so that performance will be faster and faster. We don't need to perform IO. So this is what the basic thing what happening. So whenever we request something, it will go in the memory. If it is there in the memory, then it will get the data from the memory. Otherwise, it will get from the database. It will perform one IO. Okay. This is clear? Yep. Okay. Now, let's suppose again go back to your normal system. When we double click on a file, the data will be loaded in the memory and then it will be displayed to us, right? Yes. So when data is loading from the disk to the memory, so there will be some processes which will be helping from carrying data from the disk to the memory, right? Yes. There will be some processes. So same thing here also, where we have, so here we have some processes which will be helping us to perform this operation. So together in Oracle, we say as a memory plus process is called your instance. So what is instance here? Memory plus process. Yeah. Some we say as a background processor, not as a processes we say. So what is instance? So Oracle architecture is made of two things. First is instance. Sorry, spelling mistake is there. E-N-S-T-A-N-C. It's fine. Yeah. So instance plus our database file. What is database files? Our physical files where our data are stored. That means here our physical files where actually our data will be stored. So Oracle architecture is made up of two things. First is your instance. What is instance? Memory plus processors. And physical files where our data will be actually stored. Okay. Now, now again go back to our traditional system. Let's suppose you are installing some application, maybe Skype, maybe Yahoo, or some game maybe. So when we install any kind of application here, so we are not dedicatedly allocating, okay, let's say you are installing one Skype. So we are not specifying, okay, this Skype is going to take 1 GB RAM or 200 200 MB RAM or 500 MB RAM, because a lot of application will be there. They will be sharing the RAM here.
Yes.
We are not dedicatedly allocating. But what happens in Oracle here? Whenever we install Oracle, we dedicatedly allocate. Let's say I have total 10 GB of RAM. So out of 10 GB, I will give 5 GB RAM to the Oracle itself. So whenever my Oracle application will run, so 5 GB will be dedicatedly allocated to Oracle. No other application can share that area. That means 5 GB is totally dedicated to Oracle. Only 5 GB is left for some other operation. Now no one can access that 5 GB. So that total 5 GB, that is what we say as a memory here.
Okay.
Now total this area we have 5 GB. So whenever data will come, it will come here and it will send to the data. Okay. So now we'll see the memory structures. There are a lot of structure. There are different parts in this. In memory, we have a lot of divisions here. There are different kinds of memory, different kinds of processor, different kinds of physical files. See, if you understand the architecture, the Oracle will be very easy to learn. The full concept, full DBA stuff depends on the architecture. If you're not able to understand architecture, we cannot learn.
Okay.
So I'm telling in very simple ways, that's why.
All right.
Now we'll see instance. What is instance? Now we'll talk about instance. So as I told you, what is instance? Instance is some
memory plus process.
Memory plus
process.
data. So here instance is made up of SGA. SGA plus
PGA.
Not PGA. Okay. Now we'll say instance is made up of SGA and PGA. What is SGA and PGA? We'll explain now.
Background process.
Yeah, no. SGA is your system global area and PGA is your programmable global area. Program global area, we say as it. So first what we are going to see, we are going to see the memory structure of Oracle. So in the memory structure, first term is come as a SGA. So what is SGA? This is your system global area. Now this part, this memory part is divided into the different chunks, different memory chunks. What is SGA? Simply some group of shared memory structure. Here we have different parts. I will show you what all these parts are there. The first part, the important part is our database buffer cache. So what is this? This is your database buffer cache. We say as a DBC also, or we say as a database buffer cache. So this is the one of the very important area of the SGA.
Okay.
The second part is your is a shared pool
memory.
Yeah. So this is your shared pool. Then the next is your, so these are the three main components of your database. This is your redo log buffer.
Okay.
Redo log buffer. So these are the three main components of your SGA. Apart from this, we have other components also. Like we have a large pool, Java pool, large pool, Java pool, and one more stream pool. So this is used when that kind of operation is being used. Otherwise, these three will be always used. So I will name that here. Like here we have large pool,
Java pool, stream pool,
Java pool, and stream pool. So these are the optional components. So these are the three mandatory components. So one by one we'll see all these three components. What is the use of all these three components? So first, let's come up to the DBC, database buffer cache. What is database buffer cache? So as I told you, this is the memory area which is store the copies of your data blocks read from the physical files. Physical files means, as I told you last time, that things will be read from the disk and it will be loaded in the memory, right? So
Yes.
this is the area. This is the area of our DBC where things will be stored. Let's say I'm saying the Smith information, right? So
Yes.
Smith information is stored on the disk. Here user will be requesting. Here I have one user sitting here. He's requesting something. So things will come. It will come here. It will check whether this file, the value that Smith information is stored in the DB buffer cache or not. If it is there, then it will directly redirect to the here. It will not perform any IO. If it is not there, then here somewhere you'll be having some disk.
Physical files.
Yeah, physical files, we say as a data files also, where our actually data will be stored.
Okay.
So if that thing is here, let's say this is your database, physical files. If this information is not stored here, then it will come here. It will come here. It will perform one IO from the disk here, and again it will store this information to here in the database buffer cache, and it will hand over this information to this guy.
User.
So this is the use of your data buffer cache. So this is what Oracle thought. Okay, what if we store this information in some of the memory area? But this area will be limited, right?
Yes.
This area will be limited. We cannot store all your data files. Our database will be around 35 GB, 1 TB, 2 TB, 10 TB. It can be any size, right? Depends
Yes.
on the database size. So we cannot have all data here. So what happens here? Suppose you some user asks for the Smith information, and Smith information is stored here. Okay. The next time some other user asking for some other guy's information. Next user is asking for some other. So everything will be coming here only in database buffer cache. So one time will come when this database buffer cache will get filled, right?
Yes.
Now once it is fully filled, then it will start overriding the other the last information. Like the last information was Smith, right?
Yes.
So now it will start overriding the other information. Now when this is overridden, let's say after 1 hour the Smith information got overridden with the other information. Now the next time when this guy again query the Smith information, that information is not here, right?
Again
Now,
we perform input output.
Again it will perform the IO. So this is what happens in your database buffer cache. Till here is clear?
Yes.
Okay. Now this stop board mode. Suppose this is your database buffer cache. So what happens in cache, in everything, like our data files, when we are storing data, it is stored in the form of blocks.
Yes.
Like this will be a form of blocks. It will be storing some contiguous blocks will be there everywhere. It will be storing all this information in form of some blocks. Same thing here also in database also. This is your main file database, right? So here also it will be storing as a block also. Everything will be stored as a block. So what it does here, so when we store some information, this is also, it will be stored in the form of blocks only. These are all blocks. So all information are stored in the form of blocks. Let's say Smith information is stored in this block. So when we are accessing this thing, Smith information, so whatever contents of this block will be there, that will be copied to this block.
Yes.
So the contents of this block will be, the contents of this block will be copied from here to this block. So there are different kinds of blocks in our database buffer cache. Let's say what all kinds of blocks are there. One is, we say as a buffer state.
Okay.
Buffer, we say as a buffers or we say as a blocks. So there are different types of state. The first is we say as a unused. So what is unused state? That means this is a fresh blocks or the fresh buffers which not have been used. This is open for copying for things, right? That is called your unused buffer.
Mm-hmm.
The second type is your dirty buffer. Dirty buffer. So what do we mean by dirty buffer?
Already
That means,
used.
yeah, that has been already been used here. So here, there, let's say Smith information is stored it here in this block. So this is your dirty buffer. You make as a dirty buffer. Let's say these blocks are your dirty buffer, because these three blocks, let's say, having some already some content. So these are your dirty buffers. The next type is your uh, clean. Dirty, one more type is just 1 minute. Clean buffer, yeah. So what is clean buffer? So what is happening in our database here? Let's suppose I inserted one record, right? I'm inserting some record, or I'm updating some value, right? Let's say is within EMP table is stored in this database. Here I have one EMP table stored here. So I'm modifying some EMP table values, right? Let's say I'm modifying the Smith information. Again, Smith information will be stored somewhere here. So what will happen here? This Smith information will be stored in some block. That particular block will be copied here in our database buffer cache, and then it will be modified. So now modified records are there in my buffer cache, right? That needs to be written again back to your physical files, correct?
Yes.
So there is a process called, as I told you, some processes are there which will help us to perform all this activity. So there is a process called DBWR. This is as a database writer process.
Okay.
So what it does here, whatever things we have modified here, that will be
written back to the physical files.
Exactly, it will write back to the physical files. So there are some scenarios when it will not continuously writing. So when it will write, whenever this it's not able to find the free buffers, then only it will what it does, it will modify it will flush the dirty buffers to the physical files. What is dirty buffer? That means we have modified blocks.
Okay.
What is dirty buffer? Let's say we have modified some blocks here, right? So that is called as a dirty buffer. So whatever things are there, let's say it will keep on filling. So after some time there will be a point where things will get filled. It will start overriding the data, right? So before overriding, what it does, DB writer process is there. It will flush all the dirty buffers to our physical file. So what will happen? The others buffers will be ready with the used.
Yes.
So this is called your clean buffer. Clean buffer means these buffers already contain some data, but these are already flushed to the data files. That means physical files. So now they are again ready for the use. So that is called your clean buffers.
Okay. Dirty buffers means modified.
Yeah, modified data, modified blocks. That is called your dirty buffers.
Okay.
So this is the use of your database buffer cache. Any doubt in this database buffer cache?
Clear.
Oh, okay, good. Now we'll see our redo log buffer.
So that's all about our database buffer cache.
Buffer cache, yes. Now the next is your redo log buffer. So what happens in redo log buffer? Here, yeah, this is your redo log buffer, right? What redo log buffer does?
What about shared pool?
I will come back after redo log buffer.
Okay.
So first redo log buffer. So what redo log buffer does, whatever operation we are performing in our database, whatever performance, let's say you are running one select query, we are running one insert operation, we are updating or you are deleting or any kind of operation, each and every information will be recorded to your redo log buffer. So what is the use of redo log buffer? So that, see, whatever a select statement I'm running and whenever I'm updating something or everything be recorded in the redo log buffer so that I can do recovery also.
Okay.
Here, let's say, I will draw this. So this is your redo log buffer. So again, this will be in the same form. There will be a lot of blocks. Buffers will be there like this. Lot of blocks, continuous buffers will be there. So this user, there are some users, let's say I'm doing insert operation. Okay. Then I'm performing update operation. Then I'm performing again delete operation, then again insert, update, insert, or I'm using some select statement. Like this, lot of operation is going on in my database. So what happens here? Each and every information will be recorded into the buffer. So insert operation will be recorded here. Update information will be also recorded in the block. Delete information, then again insert, whatever select statement. After some time, there will be a point come. Then this redo log buffer will get filled, right?
Yes.
So as I told you, we need to record all this information. So where to record? So again, all this information will be recorded in a file called, here there is a file called, we say as a online redo logs. We say as a redo logs. That data in the database buffer cache, things will go into the data files. These are all physical files. Again, we'll come back to the physical files. Things will go into the data files, but here things will go into the redo log file.
Redo logs.
Following the modified
Yes.
buffers in case of the database buffer cache, that will go into the data files where your actually data are stored. In redo log, what is redo log? Things from the redo log buffer to go into the redo logs.
Redo logs.
And who is the responsible for this? There is a process called log writer.
Okay.
So what is LGWR? This is the process.
And
so
for the database buffer cache, DBWR, database writer.
Database writer, DBWR. So this is the process which will be writing data from the redo log buffer to the redo logs.
Redo logs. Okay.
Now, so as I told you, so all this information, so what this process will be writing whatever things are there in this redo log buffer. So here also we'll get one insert statement. So here we'll get one insert statement, update statement, delete statement, then again update statement, because whatever things are there in the buffer, that is going to record into the redo log files. Okay. Now,
and after that, redo log buffer blocks will be deleted.
Redo log, it will keep on overriding. It will keep on overriding. Let's say the contents are filled, right? So this process is called, what is this process called? This process is called your log flush.
Okay.
Process is called your log flush. So hereafter, whenever I'm saying log flush, so what do you mean by log flush? That means contents of the redo log buffer is going to return to the online redo logs. Okay.
Okay.
This we as a refer to a redo log, or we sometimes say as a online redo logs. So when does this operation happens? At what time? Let's say whenever your 1 MB is full. This redo log buffer, whenever this 1 MB is data is there in the redo log, automatic a log flush will happen.
Okay.
Okay. Or when we say, oh, I'm sorry, not here. Redo log flush when it happen, when we say system check for it. Okay, that will come later. Okay, this till here is clear?
Yeah, it's clear.
Okay, fine. Now coming back to here, as I told you, all the information will be stored in the form of redo logs, and this is your physical file, right?
Yes.
So usually when we create a database, the default size of this redo log will be around somewhere 50 MB. Okay.
Okay. 1 second, Ashutosh. And first from redo log buffer cache, it will be written to the physical files. Then after it will be written to redo log.
No. What is physical file? Physical files, when I say physical file, that means the combination of all these files, redo log files, data files, physical files, all the physical files which we can see on the OS level.
Okay, got it.
Okay, so as I told you, so when we create our database, the default size of redo logs will be around somewhere 50 MB. The default size is your 50 MB. That means, so if the keep on writing data in this log file, so there will be some point of time this online log, this redo log will get filled, right?
Okay.
So what will happen? So whenever we install our database, so we give at least 2 redo log files. We specify at least 2 redo log files. Why 2 redo log files? Let's suppose we are writing data here, keep on writing data here. So at a certain point of time, this will get filled. So when it gets fills, then it will start writing in this redo log file, in the second redo file. So this is your first redo log file, and this is your first and second redo file. So first it will start from here, and then it will start from there. It will keep on writing in the continuous. So it will be in the cyclic manner.
Okay.
What it does, it will be in the cyclic manner. It will start in this, then it will switch the then this term is called your log switch.
Okay.
Log switch. What is log switch? Log switch means the data are being written in the first redo log file, then written in the second log file. So this is called your log switch. Log switch happened from first to second. Now again after second, it will write in the first. So what happens here? Let's suppose this redo log is filled. I have IU insert delete operation. Now it's writing into the second file. Okay, this is also get filled. Now what it does here? Now again it will start overriding the contents of this file. So what was our purpose here? To save this data, right? Whatever operations we are doing here, if we can store this, so our something goes wrong, I can see what's happened here. So this data, whatever things we are writing here, this should be stored somewhere. So for that, what's happening here? We have something called archive logs.
Archive logs. Okay.
So here we have another physical file we term as a archive log. Archive log. So what happens here? Let's suppose here the things are being written. Now log switch happened. Now things are being written into the second log file. Here is being written. Now when it is being written here, the contents of this log will be flushed into the archive logs.
Okay.
Okay. So this is called, this process is called archiving.
Okay.
ARCHIVING. This process is called your archiving. So what is archiving? Archiving is nothing but the things from your log, online redo logs, the contents of online redo logs is being written to the archive logs. That process is called your archiving. Okay. So now once it is written to the archive logs, the second time when log flush will come, then it will start overriding this data. Otherwise, it will wait for the archiving.
Okay. And what happens if archive logs get filled?
Our database will get hanged.
Okay. So we assign certain space for archive logs, right?
Definitely, because this is your physical files, right? So your database will grow as the archive logs will also grow. So what happens in real time? We regularly take the backup of archive logs, will store somewhere else. Let's say our system is having somewhere 1 TB of hard disk. Okay. So this archive logs will be generating, keep on generating, because this is the very frequent operation. Our insert, update, delete will be frequently doing, and the redo logs will be generating. So archive will be also generating, right? Yes. So whenever archives are generating, so there will be some time when let's just reset to 1 TB or let's say 500 GB or 2 GB. What we do, we'll take this backup to the external devices. We say as a tape device. So we'll store all this archives to some tape device so that the space will be free on the hard disk. So this is the one of our task as a DBA. We every day we monitor it. Every time we monitor what is the status of our archive logs, whether it is filled or not. Because once it gets filled, that means this archiving will not happen. That means this whenever redo log switch happen, it will check whether this data have been archived or not. If it has not been archived, the redo log switch will not happen. If redo log switch will not happen, that means from the contents from the redo buffer is not being written to the redo log. That means your database will get hang at that point itself.
Okay.
Okay. So this was about your redo log buffer.
And what happens if database get hanged? How we will get back to the normal process?
Simply what we do here, we'll increase the size of this destination archive logs where it is getting stored. We'll see all the scenario. So wherever it is getting stored, we'll increase the destination size or we'll delete some archive logs. First we'll take a backup of archive logs and then we'll release some space. We'll delete the old archive logs and we'll release some space.
Okay.
So again, database will start operating normally.
Okay.
So any kind of issue, some issue comes like this, we'll get one alert in our, there is a file called alert log.
Alert log. Yes.
So there we'll see, we will get this information, okay, archive log destination is full. So we'll come to know, okay, archive destination is full.
Okay.
So two things are clear, database buffer cache and redo log buffer, right?
Yep.
Okay, good. Then next will be your shared pool. We'll see tomorrow because I'm getting late for office now. It's already 8:30.
Okay.
So tomorrow be here by 6:30. We'll start the class by 6:30. Otherwise it won't finish.
Okay.
It's too huge concept.
All right. Okay.
So most probably not tomorrow. Day after tomorrow we'll be doing the installation also. Okay.
All right. Okay.
Okay. Fine. Thank you.
Thank you, Ashutosh. Thank you.
Okay. See you tomorrow 6:30. Good day. Bye.
All right. Bye.